Jai Hind. My name is Vikas. I'm an assistant professor in computer science engineering department. Today I'm going to present a topic on my presentation on the regression modeling, which is part of the data analytics there. Subject is that is BCS 052 is there. So these are my content for this presentation. What is the regression modeling is, what is the type of regression modeling, how we have steps are being needed to build the regression modeling, and what are the various challenges that we face in regression modeling is there. As we already know, we have the large amount of data sets are there, and that data sets are being continuously inflow or being stored by the in the data sets in database are there. Now as a data analytics, the role of the data analyst is to analyze those data is there. There are various certain techniques are being available on the basis of one of this is we use this regressions in order to predict the outcome on the basis of the data is being data set is being available to us are there. In the regression model generally being used when we have a continuous form of data is there, in which we have the numerical values are being there. Then in that case we use this regression modeling is there. Otherwise, if the data is in the non-continuous form, or the data set is not in the form of numerical form, then we use the classification is there. That is separate topic is there. So today we will going to discuss the regression modeling. So regression modeling is one of the most widely used and fundamental techniques in data analytics, which plays a crucial roles for identifying the relationship between the variables and by making them to predict the outcome, or you can say they understand on the basis of what is the outcome of that. So as it is regression modeling focus on the prediction of continuous dependent, as I told you, when we have the continuous data is there, then we use the regression modeling. Regression modeling focus on predicting the continuous dependent variables, which is also known as the outcome, target, or response variables are there. Based on the their independent variables, which is being used for the predictors, features, or explanatory variables are there. So we can use we receive the data from the various field are there, like finance, healthcare, marketing, or another fields are there. So regression modeling serves as a powerful tools for understanding what are the various what are the trends are there, identifying the patterns are there, and on the basis of those we make the decisions on those data sets are there. So how we understand the basic, first thing is we need to understand what is the basic of the regression modeling is there. So main objective of the regression modeling is to establish a relationship between the variables and to use the relationships to predict the future outcomes are there. So these relations often expressed in the form of mathematical equations, where the dependent variables is a function of the independent variables are there. Generally, we use these that y is equal to mx plus c is there, and we add the error are there. As these are the data sets in the form of continuous format, then we use the either, let's say, beta naught bit plus beta 1 x1 plus beta 2 x3 and so on are there. So, and we add the sum if as we add the error at the end in order to find if there is any kind of error are there. The simplest form of the regressions model is linear regressions are there, as there are various regressing models are there which are being used depending upon the types of data set that we have. In that, out of those various different regression modelings are there, the linear regression is one of the simplest form, where the relationship between the dependent and independent variables we assume it to be linear are there. So this is the linear regression models formula is there, where we have the y is equal to b naught, b1 and beta 2 into x2 and so on till we have the error function. So y is your dependent variables are there, is there, where x1 and x2 are the independent variables, or you can say that those factors can influence the outcome of the y are there. So beta 2 is the intercept representing the value of the y, where all the x variables are being 0 is there. And beta 1, beta 2 are the coefficient representing the changes, if there is, are there in the corresponding 1 unit change in the corresponding x, holding all the variables constant are there, where epsilon is the error terms is there, which is accounting for the difference between the predicted and actual values are there. For that, again, there are different methods are there in order to validate those kinds of errors are there, that we will discuss later on. So types of regression modeling, we have the multiple linear regressions, polynomial regressions, ridge and lasso regression, and logistic regressions are there. If you talk about multiple linear regressions, this extended simple linear regression by incorporating the various multiple independent variables to predict the dependent variables are there, where independent variables we already discussed that are in the form of x are there, and the dependent variables on the form of y are there. So another is polynomial regressions are there, when the relationship between the independent and dependent variables is not linear. In that case, we use the polynomial regression models are being used. So in this case, model includes higher order terms of independent variables such as your square or cube terms to capture the curvature in the data set. Sorry, I forget one point is in the multiple linear regressions, that is useful for the multiple factors to predict the outcomes such as house-based price, location, size, and number of bedrooms are there. That is with respect to your multiple linear regressions. Then we have ridge and lasso regressions. These are the variation or linear regression that introduce regularizations, where regularization means or you can techniques like ridge and lasso add the penalties to the modelers to prevent any kind of overfittings are there. So overfittings is being used in order to identify by these regression models are there, which is when models perform well on training data but poorly on unseen data are there. It means when we train our data sets, that data set is previously historical data is there, and we apply the linear regression or let's suppose any kind of regression are there. Now while training we get the better results are there, but when we train on when we provide the unseen data, then again they are giving the results as better results like your when we have a trained data sets, that will lead to overfittings are there. So overfittings are various scenario in which we can have the overfittings are there. So overfitting is one of the major problems, overfitting and underfittings are there. So this lasso and ridge and lasso regressions try to or prevent that overfittings are there. So ridge regression penalize the size of coefficient, while the lasso regressions can shrink some coefficient of 0, effectively performing the variable selections are there. Another type of logistic regression, despite its name, logistic regression used for the classification problem rather than the regression problem. It is used when the dependent variables in binary form are there, either that is 0 or 1 form or yes or no form. Instead of predicting the continuous, logistic regression predict the probability of the binary outcomes are there. And the last one is non-linear regressions. This is used when the relationship between the dependent and the independent variables cannot be adequately modeled within the linear equations are there. When we talk about the previous examples, where independent are the x variables and dependent are the y variables. So in this case, nonlinear functions such as exponentials, logarithmic or power functions are being used while we use the nonlinear regression models are there. So where these applications of the regression modeling in the data analysis that is being used, the first one is healthcare is there. In healthcare, regression modelings are used to predict the patient's outcomes, such as predicting the likelihood of developing the any kind of diseases based on their lifestyle factors, based on the various factors like lifestyles, genetics, environmental exposures, and so on are there. So linear regressions can also be used to predict the continuous variables such as blood pressure, cholesterol level, or hospital readmissions rates are there. In the finance, we use the regression modeling in order to predict the what is the stock price, what is the portfolio performance are there, and what are the various financial risks are there. So multiple regression models are particularly used for the credit scores, where the factors like income, credit history, and employment status are being used to predict the likelihood of the loan has to be given, and are the users going to default that loan or not are there. In marketing also, we use the regression modeling as are being employed to understand the consumer behavior and predict the sales are there. For example, company may use the regression modeling to impact the advertisement spends, pricing and seasonality of the sales or volume, helping the optimize the marketing strategies either. We will take the one examples on that. Regression modeling is widely used in social science to study the relationship between social, economic and political variables are there. For instance, economists use the regression modelings to predict the economic growth based on the factors like investment, inflations, or unemployment are there. So there are various steps are being used that is being in order to build a regression models are there. First thing, we need to collect the data. The first step has to be there, and that has to be in the relevant formats must be there. Then we have to pre-process those data. Data often need to be cleaned and transported, because when we receive the data, that data is in the form of raw data as there. Now we have to process the data, we have to clean the data. If there are any kind of missing values are there, then we have to take the mean, median there, depending upon the how many values are being there. If the large number of values are being missing, then we use it. Otherwise, if there are less values are being missing, then we simply delete those values are there. So we use the encoding, normalization, standard features are there. Then we perform the exploratory data analysis. Before building the models, EDA is performed to understand the relationship between the variables, detect the outliers, and get the insights about the data is there and what kind of data is there. And on the basis of that, the correlations matrix has been created are there. After that, we understand the data, what is the kind of data is that we have. Now we split the data into two parts. One is training data, another is testing data is there. There is no simple rules are there where we can say how much data has to be split into training and testing data sets are there. We can use 70-30 is there, we can use 80-20s are there. So it entirely depends on the data structures, data sets that we have received. On the basis of that, we can predict the split the data into that. Then we perform the model selection based on the problems. Hands-on appropriate regression model is selected. That model is then trained using the training data, where the algorithm estimate the coefficient and minimize the difference between the predicted and actual values are there. And if there is any kind of now after selecting training data, now we have to evaluate our data is there. We use these mean square error are there. We can use R square. We can use the MA is there in order to validate our data that is any kind of error are there. After that, we perform the model optimizations. If the model performance is not satisfactory, then we use the perform the model optimization. Otherwise, we don't use that. Then we predict after then model has been trained, tested there, then we predict the outcomes are there. And that has to be done predicted on the new or unseen data are there. So challenges are there in regression modeling. Multi-collinearity is there. Occurs when independent variables are highly correlated, leading to unreliable coefficient estimates are there. This will make it difficult to predict the determine the effect of each variables are there. So in this we take the help from the ridge and lasso regressions in order to mitigate those issues are there. If there is overfitting are there, the models fit the training data too well, but not generalized to new data is there. That phenomena is called overfitting is there. This happens when the model is too complex, or when there is a noise in the data, or when large data sets are there. For that, we perform the cross validations, and regularization techniques are commonly used to prevent the overfittings are there. Then another is heterogeneity is there, in which regression analysis assumptions is variance or any kind of error is there. When the assumptions is violated, lead to that problem is there. So in order to for that we use the weight least square method in order to address that issue is there. Another is outlier, where the certain points or certain data is there, they are not in the form of linear regressions are there. In order to detect those, we use the outlier. We identify the kind of outlier are there at while we perform the pre-processing phase are there, which is basically used to build the robust models are there. This is one problems is there. We have to predict the sales revenue. If we there to store the based on the advertising budgets, there the data set has to be consistent following the data points are there. Here in this, these are the advertising budgets are there. This is the revenue is there, and we have to see how much number of values that we have to add, how much amount that we add on the more on the advertisement, and then it will give the better results are there. So that for the simple linear regressions, we use this formula, that is y is equal to beta dot plus b1 beta 1 and x are there, where y is predicted value, x is the independent value, b naught is the beta naught is the intercept value is there, and beta 1 is the slope for the change in y for the 1 unit changes are there. So goal of linear regressions is to find the value for the this beta naught and beta 1 that are best fit the data is there. So in order to fitting the linear regressions models, to estimate the coefficient of beta naught and beta 1, we use the method called that is ordinary least square there. This method is minimize the sum of the squared error are there, if there any kind of errors are being there, and that between the actual value of y and predictive values of y are there. So for that we use this formula is there, where x naught xi minus x dash yi minus y dash and summation of xi minus x dash whole squares are there, where beta naught is equal to y dash and beta 1 is x dash are there. So x dash is the mean of the independent variables and y dash is the mean of the dependent variables are there. So xi and yi is the individual data points there in this. So applying this, first thing is we have to take the mean average of the for the x value. Then we have to take the average value of the y is there. It means sum of the all the values and divided by the number of values are there. That is in this case example 5 values are there. So we divide by 5, where this result and with respect to y is there. Now we have to compute those values in this formulas are there. Okay. After computing the values, we will get the this value. This result is there. That is beta 1 value has been identified. Now we have to identify the calculate the beta naught is there, which is being using this formula. That is beta naught is equal to y dash minus beta 1 x dash are there. So we will get the value of beta naught are there, beta 1 value is 1.3 and beta naught value is 11 are there. So we put those values in the that is y is equal to the beta naught plus beta 1 x are there. So in this case, if we apply we got this result. So now we have to find the value if how much amount that we have to spend. That in that case we will get the better revenues are there. So now we have coefficients are being identified. Linear regression equations become this there where we have to identify the that is beta naught are there, then we have to identify the beta ones are there. So this equation means that every additional unit for the 1000 spends on advertising, the sales revenue will increase by the 1.3, that is 13,000 $1,300 are there. So intercept is there where 11 is represent the baseline sales revenue. Revenue is there when no money is spent on the advertisement. Okay, so here, so using these models, now we predict the sales revenue based on the advertising budgets. For example, our budget is $35,000 are there. So we can predict the sales revenue as follows, where y is equal to x, that is beta naught plus beta 1 into x is there, where beta naught value has been identified as an 11 here, and beta 1 value is identified as the 1.3 is there. Now we have the values x is your 35 is there. So when we apply this value, we get this 56.5 is there. So thus, if the store spent $35,000 on the advertising, the model predict the value of sales revenue will be this kind of value, that is your 56,500 are there. So in this way, this linear regressions model is being used to predict the futures on the basis of the incoming inputs are there. So generally, what we do, this is the problem statements are there. Advertisement values are being given, sales revenues is being given, x and y are there. Now we have to take the using this formula, we have to apply, find the value. First we need to find the value of beta naught and beta 1. For that we have to find the mean of x and y variables are there. Then in order to do this, we use this methods are there. Then we have to compute the value beta 1. Once we get the value of beta 1, then we have to calculate the value of the beta naught are there. This way we have calculated the beta naughts are there. Now we apply those inputs value, whatever the output that we received for the beta naught and beta 1, we put there are there. Now if we want to x amount of money that we have to use, and then what will the sales, or we can say how much that we are going to get the profit are there. So if we store spend on the $35,000 on advertising, so this model will predict that that they will receive the 56,500 amount as a revenues there. So this is the linear regression models where we use the continuous or numerical data is being used when are being used for the predicting the outcomes are there. So if there any kind of errors are being there, then we use this variable mean square errors, R square and S square, and RMSE is being used. So for that, this is the formula. MSE is equal to 1 by n summation of n yi minus y dash I ka whole square are there. Y is actual output and y dash is predicted output is the n number of data points are there. So again, this is advertisement and actual sales are there. When you have to take the predictions for that, this is the values that we have to identify. We have to with respect x 24 minus 25, that we get the 1 is there, then 0.5 minus 2 1.50 is there. So by squaring those values, we get these values are there. Now we have to sum those values, and we get the mean square value for this model is 1.5, meaning that average square difference between the actual and predicted sale is 1.5 in the $1,000. Okay, so thank you.